Alright, in this video we're going to talk about exponential and logarithmic equations. So the first thing we need to talk about with exponential and logarithmic equations are one-to-one properties, as well as inverse properties. So we're going to write a few things. First, we're going to write the one-to-one property of exponential equations. So we can say that a to some power x is equal to a to some power y if x is equal to y. And then our one-to-one property for logarithms, we can say the log with base a of x is equal to the log base a of y, again, only if x is equal to y. Inverse properties, what we can do with exponential equations is say that a to the power of log base a of x is going to equal x, and that the log base a of a to the x, that'll equal x. So here's some strategies. I'm going to give you some strategies for solving logarithmic equations, and then I'm going to give you some examples which will clarify some of these inverse properties and one-to-one properties. So first, some strategies for solving exponential and logarithmic equations. So the first thing we can do is we can rewrite the original equation in a form that allows the use of the one-to-one properties of exponential or logarithmic equations, functions. Once we rewrite that, we can rewrite the exponential equation or logarithmic, in logarithmic form, and apply the inverse property. So that's what we would do if we had an exponential equation. If we have a logarithmic equation, we rewrite the logarithmic equation in exponential form and apply the inverse property of exponential functions. So now I want to look at some examples to try to talk you through how to make sense of these guidelines and strategies and properties. So let's look at example 1. And we're going to solve and round to 3 decimals. So we're going to round to the thousandths place. So our first example is going to be e to the power of negative x squared equals e to the power of negative 3x minus 4. So the strategy I would use to solve this is, since both bases are the same, we can just set the exponents equal to each other. We can go negative x squared equals negative 3x minus 4. Then I'm going to add x squared to both sides and get 0 equals x squared minus 3x minus 4. And you can utilize any method for solving a quadratic because that's what we have here. I'm going to factor, but you could use the quadratic equation. So when I factor x squared minus 3x minus 4, I know the numbers that multiply to make negative 4, that add to make negative 3, are going to be negative 4. So I'm going to have x minus 4 and x plus 1. If I set each of those factors equal to 0, we're going to find that x is equal to positive 4 and negative 1. And we have solved that exponential equation. Let's check one more out. So this will be 1b. We are going to take 3 times 2 to the power of x and set that equal to 42. Now the first thing I would do here is I would divide both sides by 3. So I'm going to be left with 2 to the power of x equals 14. And then using the strategies above, I'm going to rewrite this from exponential form to logarithmic form. So I'm going to take the log of both sides but I'm going to keep in mind the inverse properties of logs. So if I make the base of these logs 2, over here on the left, log base 2 of 2x, that's the inverse property of logs. I'm just going to get an x from that. So x is going to equal the log with a base 2 of 14, which we can use the change of base formula from the last video we had, which means that x is going to equal the log of 14 over the log of 2. And if we plug that into our calculator, we're going to get that x is just about 3.807. And we're done with example 1b. We're done with example 1. So let's look at example 2. And this is going to be another exponential equation. We're going to solve and again round to 3 decimal places. We're going to look at e to the power of x plus 5 equals 60. So when I'm doing this, the first thing I'm going to do is I'm going to subtract 5. And then I'm going to have e to the x is equal to 55. Now when I have a base in an exponential equation that is e, I'm going to take the natural log of both sides. So I'm going to take natural log of e to the x and natural log of 55, because when I take the natural log of e to the x, using my properties of logs, I'm going to end up with just x on the left side. So x is going to equal the natural log of 55, which if we round that, type it into our calculator and round it, we're going to get about 4.007. And we're done with example 2. Pretty nice so far. Let's look at another example, example 3. So we're going to solve the equation 2 times 3 to the power of 2t minus 5 minus 4 equals 11. So the first thing I'm going to do is I'm going to add 4. So I'm going to have 2 times 3 to the 2t minus 5, and that's going to equal 15. And then I'm going to divide both sides by 2. So we're going to end up with 3 to the power of 2t minus 5 equals 15 over 2. And I'm going to leave it that way for now, because I'm going to take the log of both sides, and when I take this log, I'm going to use the base I have on this exponent. So I'm going to use log base 3 of 3 to the 2t minus 5 equals log base 3 of 15 over 2, which is going to result in us getting 2t minus 5 equals log base 3, and actually we can just go 15 divided by 2 and get 7.5. Now we're almost done. Almost there. We can use our change of base to figure out what is log base 3 of 7.5, but first I'm going to move the 5 and the 2 to the other side. So we're going to add 5, and we're going to get 2t equals the log the base of 3 of 7.5 plus 5. The 5 does not go with the 7.5. And then there's one other thing. We're going to divide everything by 2. So t is going to equal, we could actually put the 5 first. 5 plus the log with a base of 3 of 7.5 divided by 2. Now I would plug this into my calculator. I would go log base 7 up. I just go log of 7.5. I'll even write that over here in blue, how I would write it into my calculator. I'd go log 7.5 divided by log 3. I'd hit enter then. Then I would take whatever that answer is, add 5 to it, and then whatever that answer is, I would divide by 2. Now what that's going to give us, if we round it, is a value that t is about 3.417. And that wraps up example 3. I think we have time for one more example, maybe 2. So example 4, we're going to solve now. For a, we're going to take the natural log of x and set that equal to 2. So to solve this, what we're going to do is we're going to take the base of the log and raise it to that expression, to both sides of this equation. So the base of the natural log is e. We're going to raise e to the natural log of x, and we're going to take e and raise it to the power of 2. Now if we take any base and raise it to a log with that base, we're just going to get what follows the log. So we're going to have x on the left. So x is going to equal e squared. You can type e squared into your calculator. You can even just leave it as e squared. So we're done with A. B, we're going to take the log with a base of 3 of 5x minus 1, and we're going to set that equal to the log also with a base of 3 of x plus 7. So using the one-to-one properties we talked about, these logs have the same base. As long as that's true, then that means 5x minus 1 has to also equal x plus 7. So we're going to solve these for x. We can subtract x from both sides. We'll have 4x minus 1 equals 7, and then add 1. So 4x equals 8, and then we can divide by 4. And we find that x is equal to 2. And we're done with 4b. I also have a c that I want us to look at. So example 4c, we are going to take log with the base 6 of 3x plus 14, and subtract log with a base 6 of 5, and that's equal to log with a base 6 of 2x. So first, let's condense what's on the left to one logarithmic expression. When we subtract like this, we can use the division property to rewrite this as the log with our base 6 of 3x plus 14 divided by 5 equals the log base 6 of 2x. And then we can use the one-to-one property. In order for these to work, that means 3x plus 14 divided by 5 has to equal 2x. So we're going to multiply both sides by 5 to move it. Well, 2x times 5 is going to give us 10x on the right, and on the left we're going to have 3x plus 14. So we're going to subtract 3x. We're going to get 14 is equal to 7x, and then if we divide both sides by 7, we'll get that x is equal to 2. And we're all done with that example 4. I do have a couple more examples I want to go over. They'll be in our next video.